Now see, we know this thing in our day-to-day life also we can observe this thing. If any body, any substance that is at higher temperature compared to its surrounding temperature, then slowly that particular body will cool down, because from the body to its surrounding the heat will flow, right? And scientist Newton suggested this thing: the rate of loss of heat by the body, that is rate of flow of heat, that we write dq by dt, but here heat is lost by the body, so we introduce the negative sign here. So rate of loss of heat, that is minus dq by dt of the body, that directly proportional to the temperature difference of the body and its surrounding. Okay, say suppose T, that is the temperature of the body at any instant, we can say that is T2 also. And Ts, that is its surrounding temperature, we can say that is T1 also. Okay. Then the temperature difference, that we can write T minus Ts, or we can write that is T2 minus T1 also. Okay. Now, the rate of loss of heat minus dq by dt, that proportional to T2 minus T1. So minus dq by dt, that is equal to k into T2 minus T1. But say here we already discussed this thing, the transfer of heat, or you can write delta q also, that is equal to ms delta T. For the small temperature difference, you can use the notation this delta T as dt also. So dq by dt, that is ms dt by dt. Both side is divided by dt. Now, this dq by dt, that we can replace by k into T minus Ts. Okay. So here we can compare these two equations. So minus ms dt by dt equal to k T minus Ts. Okay. So minus dt by dt equal to k upon ms into T minus Ts. Again, this k upon ms is constant, so another constant is introduced here. This one k into T minus Ts. So actually in Newton's law of cooling, you have to think about the equation, this one, or this particular equation. You have to think about these two only. Okay, clear up to this one? Now we can rewrite this one as dt by T minus Ts equal to minus k dt. Now integrate on both the side. So on left hand side, the integration, that is log at the base of e, or ln T minus Ts equal to, on right hand side, minus kt plus the integration constant. So we can write T minus Ts equal to e raised to minus kt plus c. So here we can write T equal to Ts plus e raised to minus kt plus c. So if we draw the graph of ln T minus Ts versus time t, then that will be the straight line graph. This is the Newton's law of cooling. Example 11.8. A pan filled with hot food cools from 94 degrees Celsius to 86 degrees Celsius in 2 minutes when the room temperature is at 20 degrees Celsius. How long will it take to cool from 71 degrees Celsius to 69 degrees Celsius? Now see, as per Newton's law of cooling, we can write minus dt by dt equal to k into T minus Ts.